Hello everyone, and we're going to continue our 2015 MONBUKAGAKUSHO solution video. And first, we're gonna look at the question, part 2, number 2 of Mathematics B 2015. So, we're gonna draw a circle C on a plane and put n distinct points on the circumference of C. Join any two of the endpoints and it form a chord. Suppose that no three chords intersect at any one point inside C. Let Cn be the number of such chords, In that of the intersection of the chords inside C, and Rn that the regions in C bounded by an arc and or some chords. Fill in the blanks with the answers to the following question. Find C1, C2, C3, C4, C5, C6 and write their values in order. Find I1 to I6, R1 to R6, and we're gonna express Cn, In, Rn with binomial coefficients in terms of n. Now, let's see for problem 1. We're gonna find how much is C1, C2. So C1 meaning that in the circle, like this, there are actually only 1 point. So this is the definition, the way to do it. Meaning that if there are only 1 point at the circle, is there any chords right there? Of course not, because the circle has only 1 point. So the answer for C1 is in this box is actually 0. And let's find for C2. For C2, there are 2 points, so the value of chords is 1. So C1 is 0, C2 is 1, and if there is 3 points, the chords is 3. Then for 4 points, which is C4, let's say 1 point here, we can make it this way. There's another type of chord here, this 2, and this line 2. So we got 1, 2, 3, 4, 5, 6. There are 6 chords, and if there are 5 points, let's say 1 point is there, then we're gonna combine the line there, and here, and here, and here. It's still like a star, so to calculate, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. There are 10 chords. And if there are 6 points, let's say 1 point is there, so 1 there, and then here, here, and here. Okay, so that is the C6. And let's calculate that. There are 1, 2, 3, 4, 5, 6, and then 7, 8, 9, 10, 11, 12, 13, 13, 14, and one more. Is there any other lines that I miss? 14, 15. Yeah, there are 15 chords. Now, 0, 1, 3, 6, 10, 15. We're gonna paste it here. 0, 1, 3, 6, 10, 15. So that is the way to actually do it. Easy, right? Okay, so I6 now. I6 is stated to be some kind of number of intersection of the chord C. Okay, so let's draw another circle. I'm not pretty good at drawing circle, by the way. Okay, so for this particular circle, we're gonna draw it 1 point. There's no intersection, right? C2, 2 points. Of course, there is no intersection. And for C3, or let's join this line. And for C3, well, even if the state is in this position, then there is no intersection. And for C4, You see, there's one intersection down there in the middle. 1, C5. Now we are getting a little bit bigger. Well, I think I drew it the wrong way. What I meant is just connect all the points in the circumference, not for in the middle. Then we have to draw that line there. Yeah, so let's calculate. Is there any lines? Okay, 1, 2, 3, 4, 5. And there's 5 intersection. For 6 points, and that's the line there. Go down there, go down there, and this is going here. Okay, there's the point there. It's there. Just want to check whether I miss some line or should I add some more. I think that's it. So let's count the intersection. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there are 15 intersection at this problem 2 of 6 points. So this 0, 0, 0, 1, 5, 15. We're gonna paste it 0, 0, 0, 1, 5, 15. And for problem 3, it's R. R is just a region that is covered by the chord or any line. So meaning that this is R, the region. So this is 1 region, 2 region, and others. For that, we're gonna draw another circle for our third problem. So there's one circle again that we have to draw. For 1 point, there is 1 region, right? Because the circle is a curve. It's like a full curve, 360 degrees. So C1 is 1. I mean R1 is 1. And for 2 points, there are 2 regions. So R2 is 2. And for 3 points, there are 1, 2, 3, 4 regions. And for 4 points, there are 1, 2, 3, 4, 5, 6, 7. Is 7? Oh wait, 1, 2, 3, 4, 5, 6, 7, 8. Oh, it's 8 regions. And for 5 points, I think there's a lot of region and only this points here. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 points. Now I just want to erase the dots here so it not confuse me when I draw the 6 point. Now for the 6th point, we're gonna add it this way, and this even got more region, which we should aware if we actually have missed another line. I think there's not any side that we missed here. Okay, so let's count the region, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. Oh, there are 31 region covered by 6 points, and we just connect these 2 points in the circumference to make a chord. So there are 1, 2, 4, 8, 16, 31. So I'm gonna paste it. 1, 2, 4, 6, 8, no, 1, 2, 4, 8, 16, and 31. Now the last problem here, which they ask us to make a binomial coefficient to express the Cn, In, and Rn in the coefficients of m and k. So basically, we're actually gonna turn this C1 to C6, R1 to R6, and I1 to I6. So if they start with 0, so we're gonna express C first, C1 to C6, meaning that if you first, if you don't actually understand binomial coefficient, this is how it is actually done. So m factorial, if mk, then it is equal to m factorial over k factorial times m minus k factorial. So for example, if you have 3 and 2, this will be equal to 3 factorial over 2 factorial. 3 minus 2 is 1 factorial. So this is equal to 3. But if you have something that is 2 and that is less than, for example, 5, then it's equal to 0. So if this declared as 0, meaning that the coefficient of m, so m is for 1, 2, 3, 4, 5, 6. So if this is the first point, so this is 1, and what's smaller than is for example 2. And to get 1, remember, in binomial coefficients, if you want to have the value is 1, meaning that the value here of m and the value of k should be the same. If it is less than, if m is less than k, then the answer is 0. And if m is bigger than k, then m is bigger than 1. And for the third, so 3, 2, yep, it is, the answer is 3. So the binomial coefficient for C1 to C6 is n2. Now for In, I1 to I6, so we have 0, 0, 0, meaning that for the first 3, it resulted in 0. So it could be resulted in n4, actually the binomial expression, right? If there are 1 point, it's 1, 4, 0, and then second point 0, and the third point is 0, and the fourth point is 1. So this is n4. Now for the third problem is Rn, and they had already the value which is 1. But we cannot just make the constant of m and k is 1, right? This is actually equals to 1. But what if we have 2, 1? Then the result would not be as equal to what we actually think of. This is actually 2. And for 4 and 1, I just want to make another type of calculation here. So this is 3, 1, the third point. But 3, 1, I mean for the third point here, is not 4. But this answer is 3. So the value of, let's say you answer n1 is incorrect. So the correct solution for the third binomial coefficient is actually 1 plus n2 plus n4. So we're gonna prove it. If we got the first point, this is equal to 1 because this is 0 and this is 0. And for the second point, this is 1 and this is the same, it is 1, and this is 0. So this is equal to 2. And let's say we want to find for the sixth point. So 6, 1 plus 6, 2 plus 6, 4. This is equal to 1 plus, so 6 factorial, 2 factorial, 4 factorial, plus 6 factorial, 2 factorial, 4 factorial, and 2 factorial. So this is 1 plus 15 plus 15. This is 31. So the answer for the binomial expression of the Rn is 1 plus n2 plus and 4. And this is for the part 2, and for the next video we're going to discuss part 3 of binomial coefficients. And this is the answer for number 2. It's just whether you actually able to draw the chords, you identify the intersection, and you identify the region. And finally, when you already have the correct answer of Cn, In, and Rn, we should carefully understand on how to actually form and have a good logic on actually understanding the binomial expression for each of this value of Cn, In, and Rn. Thank you for watching.